Good morning. Our today's discussion is about addition of ammonia and its derivatives to a carbonyl group. Addition of ammonia and its derivatives to a carbonyl group or aldehyde or ketone. Formula of ammonia, it is NH3. Formula of ammonia, it is NH3. See, in NH3, nitrogen contains what? Nitrogen contains lone pair of electrons. Nitrogen contains lone pair of electrons, and these lone pair of electrons can be readily donated. It can be readily donated. So, since nitrogen atom, since it readily donates pair of electrons, ammonia, it is considered to be a nucleophile. Ammonia, it is an example for what? Example for nucleophile. It is also called as Lewis base. Ammonia, it is also an example for Lewis base. I will repeat once again. So, ammonia, it is an example for nucleophile or Lewis base. What is nucleophile? Nucleophiles are electron rich species capable of donating electrons. Capable of donating electrons. So, here in ammonia, nitrogen donates pair of electrons. So, it is said to be a nucleophile or it is a Lewis base. We are studying nucleophilic addition of ammonia and its derivatives. How derivatives are obtained? Derivatives of ammonia, they are obtained. For example, amine. General formula of amine, it is RNH2. RNH2. So, RNH2, it is an example for a derivative of amine. So, see this compound, it is obtained by replacing one of the hydrogen atom by an alkyl group. One of the hydrogen atom must be replaced by an alkyl group, then we will get an amine. We will get an amine. So, amine, it is an example for a derivative of ammonia. Some more examples we can write. NH2 OH, this is hydroxyl. OH group means hydroxyl. Hydroxylamine. NH2. What is this? NH2 Hydrazine. NH2 it is what? Hydrazine. So, amine, hydroxylamine. What is this? Hydrazine. Still more examples we can give. Phenylhydrazine, 2,4 dinitrophenylhydrazine, and one more, that is semicarbazide. So, amine, hydroxylamine, hydrazine, phenylhydrazine, 2,4 dinitrophenylhydrazine, semicarbazide, they are examples for derivatives of ammonia. So, generally we can represent a derivative of ammonia like this. I will write NH2, one of the hydrogen, it is replaced by some other group, let us take it as Z. So, NH2Z represents derivative of ammonia, represents what? Derivative of ammonia. So, before writing the reactions with these compounds, let us write the mechanism, general mechanism of addition of ammonia to a carbonyl group. We are writing what? Addition of what? Addition of ammonia or its derivative to a carbonyl group. See, carbonyl group, it is written like this, C double bond O, or this is aldehyde or ketone. It is made to react with derivative of ammonia. So, this is derivative of ammonia. So, in this derivative we can see nitrogen atom with lone pair of electrons. This is also nucleophilic addition only. So, this nitrogen will attack the positive center or positively charged carbon. Electrons gets shifted to oxygen. Shifted to oxygen. So, reaction, it is a reversible reaction. It is C single bond O minus. What about the nucleophile? That is NH2 NH2Z, correct? NH2, I'll write it like this. This is NH2Z. See, nitrogen loses lone pair of electron, so we have to write positive charge here, positive charge upon nitrogen. Now what happens? Nitrogen, we know that it is more electronegative. Usually it carries negative charge or it is electron rich. But here, after the donation of lone pair of electron, a positive charge is created upon nitrogen. So since there is a positive charge upon nitrogen, this nitrogen, it will start attracting the electrons of hydrogen atom, because this bond, it is a polar bond. NH bond, it is a polar bond. So electrons start moving like this. So it will accept pair of electrons from nitrogen hydrogen bond. So both electrons will be shifted to nitrogen. As a result, hydrogen, it will be removed in the form of H plus, in the form of what? H plus. And this H plus, it is added across what? Across O minus. That is, see here, it is C, O minus becomes OH. O minus takes up H plus, forming OH. Here what I have to write? It is NHZ. NHZ. Now no positive charge. Now there is no positive charge upon nitrogen because it has got what? Pair of electrons from nitrogen hydrogen bond. So it is NHZ. This is intermediate. What is this? Intermediate. And this intermediate loses water. This intermediate loses water. So a molecule of water is removed. So once water molecules are removed, we will get what? It is C. If OH is removed from carbon and hydrogen, if it is removed from nitrogen, so there exists what? There exists a double bond between carbon and nitrogen. It is C double bond NZ. So this is the final product. So directly I can write the intermediate and final product. So this is C OH NHZ. We call it as intermediate. This is intermediate. This intermediate in the next step undergoes elimination, or a molecule of water is removed. Molecule of water is removed. That is C double bond, because carbon loses its one of its bond, nitrogen also loses one of its bonds, correct? So it is double bond NZ plus it is H2 plus it is H2. So this is the general mechanism. Now let us discuss the reactions one by one. First one, addition of ammonia. Addition of what? Addition of ammonia. Formula of ammonia, it is NH3. Let us write the same mechanism. C double bond O plus NH3 plus what? Plus NH3. Nucleophilic attack upon carbon. Upon what? Upon carbon. Reaction, it is a reversible reaction. It is C. This becomes OH NH2. It is what? It is NH2. Last step. Elimination of water. Remove molecule of water. OH is there. We have to remove one hydrogen from this. That is C double bond. It becomes NH. C double bond NH. This is called as amine. In Stephen's reaction already we studied C double bond NH group. It is called as what? It is called as amine. What is this? Amine. So aldehydes and ketones reacts with a molecule of ammonia to form what? To form amine. to form imine. Same reaction can be shown in single step. That is just by writing the removal of water. We can write the equation, that is C double bond O. We are writing NH3. I will take it as H2 NH. H2NH. So removal of water takes place forming what? It is C. What is there here? It is double bond NH plus H2O. Imine along with water. See, for the exam, you just write this equation. No need to write the mechanism. That is, writing the intermediate first, then loss of water forming the final product. That is, imine or substituted imine, anything. So, for the exam, just write it in single step. That is, aldehyde or ketone reacts with ammonia. Since we have to show the removal of water, we are writing it like this. H2NH, C double bond O, H2NH, removal of water, giving C double bond NH. This is imine along with water. Along with what? Along with water. I will continue. Next, second one. Addition of amine. Addition of what? Amine. Amine we know. Functional group of amine it is NH2. General formula of amine it is RNH2. It is what? It is RNH2. Let us write the equation. So it is C double bond O. C double bond O represents aldehyde or ketone made to react with amine. That is RNH2. RNH2. See, mechanism it is like this. Nucleophilic attack upon positively charged carbon. Intermediate will be formed. That is C. What we have to do is, let us write one of the hydrogen along with the oxygen. That means it should become OH. Remaining group it is NHR. NHR. It is very easy. What is nucleophilic addition? In the beginning itself I told you, nucleophilic addition means addition of H plus across oxygen and addition of nucleophile across carbon. This one you have to remember. So, see, nucleophilic addition means what? Addition of hydrogen, H plus ion across oxygen and addition of nucleophile across carbon. Same thing it is happening here also. See, H it is added across what? Across oxygen, across carbon, nucleophile. Which is the nucleophile? It is NHR. Remaining group you have to write NHR. This is intermediate. Next step, loss of water. Loss of water giving what? It is C. Due to the loss of water, carbon loses one of its bond, nitrogen also loses one of its bond, so double bond we have to write. It is double bond NR. Double bond NR. See, it is just like imine only. Imine formula we can write it like this. It is C double bond NH. But what about this one? It is C double bond NR. Hydrogen it is replaced by a substituent group. Hydrogen it is replaced by what? By a substituent group, that is alkyl group. So it is called as substituted imine. It is called as what? Substituted imine. It is also called by the name Schiff's base. Also named as what? Schiff's base. So Schiff's base, or it is substituted imine. Let us write this equation in single step. C double bond O, C double bond O plus, we have to show the removal of water. I can write it like this. It is H2 NR. H2NR, removal of water. It is C double bond NR plus H2O plus what? Plus H2O. This is substituted imine, also called as Skiff's base. This is the second reaction. Next, third one. Addition of hydroxylamine. Addition of hydroxylamine. Formula of hydroxyl, it is OH. Amine means NH2. So hydroxylamine NH2OH. NH2OH. I will write the equation in one step. C double bond O. What I have to show? Removal of water, correct? So I will write it like this. It is H2NOH. You have to write hydroxylamine as H2NOH. Removal of water, write the remaining thing, that is C, then it is double bond, here it is NOH plus H2O, this product it is called oxime, product it is named as oxime. So if an aldehyde reacts with hydroxylamine, it is called as aldoxime. Reaction of aldehyde with hydroxylamine produces aldoxime. Reaction of ketone with the hydroxylamine produces what? Produces ketoxime. So generally it is oxime. Generally product it is named as oxime. If it is aldehyde, it is aldoxime. If it is ketone, it is ketoxime. Next, fourth one. Addition of hydrazine. Addition of what? Addition of hydrazine. Formula of hydrazine NH2 or it is N2H4 NH2. Let us write the equation. C double bond O, aldehyde or ketone, it is made to react with hydrazine. How do we write this? It is H2, because we have to show the removal of water. H2N, then it is NH2. NH2. Removal of water, product form, it is C, then it is double bond, here it is N, single bond NH2 plus H2O, plus what? Plus H2O, product it is called hydrazone. Product it is named as what? Hydrazone. So with the hydroxylamine it is oxime, with the hydrazine it is hydrazone. So aldehydes and ketones reacts with hydrazine forming hydrazone. Forming what? Forming hydrazone. Next, fifth one. Addition of phenylhydrazine. Addition of what? Phenylhydrazine. Formula of hydrazine, it is NH2. Formula of hydrazine NH2. Phenylhydrazine. Formula of phenyl group. Phenyl means C6H5. C6H5, this group it is called as phenyl group. This group it is named as what? Phenyl group. Let us replace one of the hydrogen by C6H5. There are totally 4 hydrogen atoms. I will remove one hydrogen and in the place of hydrogen I will add C6H5. Then it becomes what? C6H5 NH2 becomes NH. I replaced one of the hydrogen by C6H5. It is NH2. NH2. So phenylhydrazine, it is obtained from hydrazine only by replacing one of the hydrogen by phenyl group C6H5. C6H5 means benzene ring. Benzene ring NH2. NH2. So this is phenylhydrazine. I will write the equation. Aldehyde or ketone, C double bond O plus it is phenylhydrazine. H2 we can see here. That is H2 NH C6H5. H2N NH C6H5. Removal of water. Product formed, it is C double bond, it is NH C6H5 plus H2O plus what? Plus H2O. What is the name of this product? Product formed with hydrazine, it is named as hydrazone. With phenylhydrazine, product it is named as phenylhydrazone. So product formed it is named as what? Phenylhydrazone. So hydrazine, reaction of aldehyde with hydrazine produces hydrazone. Reaction of aldehydes and ketones with phenylhydrazine produces phenylhydrazone. Phenylhydrazone. Next, 6th one. Addition of 2,4 dinitro phenylhydrazine. 2,4 dinitro phenylhydrazine. It is also abbreviated as DNP. It is what? DNP. DNP means 2,4 dinitro phenylhydrazine. See, test it is called DNP test. DNP means 2,4 dinitro phenylhydrazine test, and DNP test this is a general test. It is what? It is the general test used for the detection of carbonyl group. So presence of carbonyl group in an organic compound. Presence of carbonyl group in an organic compound. It is detected by using DNP test. DNP test, it is a common test for aldehydes and ketones. Now let us write the structure of 2,4 dinitro phenylhydrazine. We know the structure of phenylhydrazine. Let us write it first. Phenyl means benzene ring. Then it is NH2. See, C6H5 NH2. We have to introduce two substituent groups at carbon number 2 and carbon number 4. This is carbon number 1 because it contains a functional group, carbon number 1. This is second one. Here I have to write NO2. This is second position. Third one, Fourth position again I have tried NO2. NO2. Now this is 2,4 dinitrophenylhydrazine. 2,4 dinitrophenylhydrazine. Without writing the benzene ring, we can't write the structure of 2,4 dinitrophenylhydrazine. It is C double bond O, aldehyde or ketone. It is made to react with phenylhydrazine. Sorry, 2,4 dinitrophenylhydrazine. H2N, NH, then it is aromatic ring, benzene ring, NO2, second position, third one, fourth one, again it is NO2. Remove water, H2O. I can complete the equations. It is C, then it is C, then it is double bond N, NH, then aromatic ring containing nitro groups at second position and fourth position. Second and fourth position. Now product name, with hydrazine it is hydrazone, with phenylhydrazine, phenylhydrazone, with 2,4 dinitrophenylhydrazine it is 2,4 dinitrophenylhydrazone. 2,4 dinitrophenylhydrazone. This test it is called as what? DNP test. Purpose of using DNP test, this test it is used to detect the presence of carbonyl group, that is aldehyde, or whether the given compound, whether it is aldehyde or ketone. To check whether it is aldehyde or ketone, we can use this test, DNP test. Last one. Seventh one, addition of semicarbazide. Addition of semicarbazide. See, formula of semicarbazide, it is easy to remember. We know the formula of urea. Formula of urea, it is NH2CO NH2CO NH2. This is urea. Formula of semicarbazide, NH2 NH CO NH2. NH2 NH CO NH2. What we have to do is we have to replace one of the hydrogen by NH2 group. Replace one of the hydrogen by NH2, then we can write the formula of semicarbazide, NH2 NHCO NH2. This is semicarbazide. First write the formula of urea, NH2CO NH2. This is familiar, NH2CO NH2. Replacing one of the hydrogen by NH2 group, I can get semicarbazide, that is NH2 NHCO NH2. NH2 NHCO NH2. Let us write the equation. C double bond O plus it is NH2 NHCO NH2. This is semicarbazide. Removal of water. We can't remove water from this NH2 group because it is directly bonded to electron withdrawing carbonyl group. Electron withdrawing carbonyl group. Removal of hydrogen becomes difficult. So it is C, then it is double bond N, NH, CONH2, NHCO, NH2 plus H2O, product it is called semicarbazone. Reagent name it is semicarbazide, product name it is semicarbazone. So this completes addition of ammonia and its derivatives. With ammonia, amine is obtained. With amine, substituted amine or Skipp's base is obtained. With hydroxylamine, it is oxime. With hydrazine, it is hydrazone. With phenylhydrazine, product it is phenylhydrazone. With 2,4 dinitrophenylhydrazine, product formed it is 2,4 dinitrophenylhydrazone. With semicarbazide, product formed it is semicarbazone. Don't use this NH2 for the removal of water, because this NH2 it is directly bonded to electron withdrawing carbonyl group. So removal of hydrogen becomes difficult. So we are using this hydrogen, NH2, NHCO, NH2. So it is C double bond NNHCO, NH2. Product it is called semicarbazone. This completes nucleophilic addition reaction. See this reaction, it is also called as, what is this actually? First step addition, next step removal of water. So addition followed by elimination, it is also called as condensation reaction. Condensation reactions of aldehydes and ketones. Condensation means chemical reaction which involves removal of small molecules like water, alcohol, etc. In a chemical reaction, if there is a loss of water or alcohol, then that reaction it is named as condensation. Here also in this nucleophilic addition, removal of water takes place. So this reaction can also be named as condensation reaction. Next one, reduction. Reduction of aldehydes and ketones. In that first one, reduction to alcohols. See, aldehyde, formula of aldehyde it is RCHO, or it is R C double bond O single bond H. When it is reduced by using hydrogen in the presence of nickel, platinum or palladium, what is reduction? Addition of hydrogen. For the addition of hydrogen, we need either platinum, nickel or palladium catalyst. So addition of hydrogen in the presence of catalyst, it is reduction, or it is also called as catalytic hydrogenation. Hydrogenation means addition of hydrogen molecule. See, there are two hydrogen atoms. Out of these two, one of the hydrogen, addition always takes place across multiple bond. Addition reaction takes place across multiple bond. So one of the hydrogen it is added to carbon, other hydrogen it is added to oxygen. So as a result, we will get out it is RCH. Initially it was C, now it is CH, single bond H, double bond reduces to single bond OH, or it is RCH2OH. This is primary alcohol. So reduction of aldehyde gives out primary alcohol. Reduction can also be carried out. Reduction of aldehyde can also be carried out by adding reducing agents. Aldehydes can also be reduced by using reducing agents like lithium aluminum hydride or sodium borohydride. Lithium aluminum hydride or sodium borohydride. Again same thing. two nascent hydrogens. We need one of the hydrogen, it is added to carbon, other hydrogen it is added to oxygen. So it is our CHH single bond OH, single bond OH. So addition of hydrogen across the multiple bond, that is carbon oxygen double bonds. Again this is primary alcohol. It is our CH2OH primary alcohol. See, ketone means on either sides we have alkyl groups. It is our C double bond O R. When it is subjected to reduction either by passing hydrogen in the presence of nickel or by using lithium aluminum hydride or sodium borohydride, addition of hydrogen takes place here. That is our CH. One of the hydrogen it is added to carbon, single bond OH, single bond R. This is secondary alcohol. So reduction of aldehyde produces primary alcohol. Reduction of ketone produces secondary alcohol. What is reduction? Addition of hydrogen across multiple bond, that is carbon oxygen multiple bond. For reduction either we can use catalytic hydrogenation, that is passing hydrogen gas in the presence of catalysts like nickel, platinum or palladium, or we can use reducing agents like lithium aluminum hydride or sodium borohydride. This is about reduction to alcohols. Next, second one, this is very important, reduction to hydrocarbons. So reduction to hydrocarbon means reducing carbonyl group to CH2 group. Carbonyl group to CH2. CH2 means methylene. CH3 it is methyl group. CH2 it is methylene group. So converting C double bond O to CH2. If I convert C double bond O to CH2, then it becomes a hydrocarbon. See, conversion of carbonyl group or conversion of aldehyde or ketone into hydrocarbon, this can be done by using Clemmensen reduction. This can be done by using hot Clemmensen's reduction, or there is one more reduction called Wolff-Kishner reduction. Let us explain this first, then we shall move on to Wolff-Kishner reduction. Now what is Clemmensen's reduction? See, in Clemmensen's reduction, aldehydes or ketones, they are subjected to reduction. We know that for reduction we need reducing agent. Reduction it is carried out by adding reducing agent. Reducing agent used here, that is zinc amalgam, zinc mercury mixture, zinc amalgam in concentrated HCl. Zinc amalgam in concentrated HCl. So this is the reducing agent used in Clemmensen's reduction. So when aldehydes or ketones, when they are reduced by using zinc amalgam in concentrated HCl, hydrocarbons are formed. This reaction it is named as Clemmensen's reduction. Clemmensen's reduction. Repeat, what is Clemmensen's reduction? Clemmensen's reduction means reducing aldehyde or ketones to hydrocarbon by adding a reducing agent, that is zinc amalgam dissolved in concentrated HCl. I will write the equation. Aldehyde or ketone means C double bond O. C double bond O represents aldehyde or ketone. It is subjected to reduction. Reduction means addition of hydrogen, that is nascent hydrogen, by using zinc amalgam and concentrated HCl. See, if you are using reducing agent, then you have to write nascent hydrogen only. If we are using catalyst, then we have to write H2. Don't get confused. H2 is written when we are using a catalyst. Hydrogen molecule is written when we are using a catalyst. Suppose if we are using a reducing agent, then we have to write hydrogen inside the square bracket. We call it as nascent hydrogen. Nascent hydrogen, or it is newly born hydrogen. Newly born hydrogen. So, aldehyde or ketone subjected to reduction by using reducing agent zinc amalgam in concentrated HCl. What happens to C double bond O? What is reduction? Removal of oxygen, addition of hydrogen. Removal of oxygen, addition of hydrogen. So, here we can see one oxygen atom. Remove this oxygen. In the place of oxygen, you add hydrogen. See, we know that oxygen, it is divalent. Hydrogen, it is what? It is monovalent. Hydrogen, it is what? Monovalent. Suppose if we are removing one oxygen, then we have to add two hydrogen. In order to complete the valency, in the place of one oxygen, I have to add two hydrogen. Understood? So, oxygen, since it is divalent, in the place of one oxygen, we are adding two hydrogen. Okay, I will remove this oxygen. In the place of oxygen, I will add hydrogen. I can't add one hydrogen, valence will not be satisfied. So, I have to add two hydrogen, CH2. Oxygen, it is removed in the form of water, H2O. In the form of what? In the form of water. Totally 4 hydrogen. So, this is 4 moles of nascent hydrogen. 4 moles of nascent hydrogen. For example, CH3, C double bond O H. C double bond O H. Common name of this compound, this is acetaldehyde. Acetaldehyde, subjected to reduction by using zinc amalgam in concentrated HCl. Zinc amalgam in concentrated HCl. In the place of CO, you write CH2. So, it is CH3, CO is there, what I write? CH2, single bond H, or it is CH3, CH3, this is ethane, C2, H6, C2, H6. We can take ketones also, see, acetone, formula of acetone, it is CH3, C double bond O, CH3, it is subjected to reduction by using zinc amalgam in concentrated HCl. In the place of CO, I have to write CH2. I have to remove oxygen, and in the place of oxygen, I have to add hydrogen. So, it is CH3, first one. In the place of CO, I have to write CH2. Then it is CH3 plus H2. Here also plus H2. So, this is Clemmensen's reduction, important for the exam. So, Clemmensen's reduction means when aldehydes or ketones, when they are reduced by using zinc amalgam in concentrated HCl, hydrocarbons are formed. This reaction, it is called as Clemmensen's reduction. Next one, second, it is Wolff-Kishner reduction. First one, it is Clemmensen's reduction. This is Wolff-Kishner reduction. This reduction, it is also used for the conversion of carbonyl group to methylene group. Carbonyl group to methylene. So conversion of CO to CH2. It is done either by using Clemmensen's reduction or by using Wolff-Kishner reduction. Wolff-Kishner reduction. In the case of Wolff-Kishner reduction, reducing agent used is NH2 NH2. NH2 NH2. Just now I told you NH2 NH2 means it is hydrazine. What is this? Hydrazine. I will write the equation. Aldehydes or ketones. This is aldehyde or ketone. C double bond O. Treated with hydrazine. Treated with hydrazine. Remove water. You know how to remove water. Okay, so product formed, it is C double bond NNH2. This is hydrazone. Hydrazone along with water H2O plus what? Plus water. So what is the first step? In the first step, aldehyde or ketone, it is treated with hydrazine, a reducing agent, hydrazine. With the removal of water, hydrazone is obtained. Hydrazone is obtained. Now this hydrazone, in the next step, it is heated. Hydrazone, it is heated by using a base. Either we can use sodium hydroxide or we can use potassium hydroxide. I will take potassium hydroxide, KOH, dissolved in ethylene glycol. Ethylene glycol means dihydric alcohol. It is a higher boiling solvent. Higher boiling solvent. So KOH dissolved in a solvent, ethylene glycol. Hydrazone, formed hydrazone, it is heated in KOH, dissolved in what? Dissolved in ethylene glycol. What you have to get? You have to get hydrocarbon. Hydrocarbon means CO2 CH2. So initial component was CO, it should be converted to CH2. CH2. What is remaining? N and N. You write N and N as N2. It is what? It is N2. So CH2 plus N2. So by this way we can convert aldehydes or ketones into what? Into hydrocarbons. So first we have to treat aldehyde or ketone with hydrazine. Hydrazone will be formed. Heat that hydrazone by adding KOH, potassium hydroxide or sodium hydroxide in ethylene glycol. With the removal of N2, hydrocarbon will be obtained. That is CH2. For example, I will take acetone, CH3, C double bond O, CH3. In order to show the removal of water, I wrote C double bond O like this, plus hydrazine. It is H2N NH2. H2N NH2. Remove water. Write the product. It is CH3, single bond C, single bond CH3. Then it is double bond. Here it is NH2. NH2. This is hydrazone along with water. No need to write water. Next, heating it with KOH in ethylene glycol. KOH in ethylene glycol. Remove nitrogen N2. So it is N2. Write the remaining thing, that is CH3 CH3, don't write double bond, write H2. It is CH3 CH2 CH3. This is propane. So reduction of acetone by using hydrazine followed by heating it with KOH in ethylene glycol produces N-propane. N-propane, this reaction, it is nothing but Wolff-Kishner reduction. See, in Wolff-Kishner reduction as well as in Clemmensen's reduction, we are converting carbonyl group to CH2 or conversion of aldehydes or ketones into hydrocarbons. Now, what is Wolff-Kishner reduction? See, in Wolff-Kishner reduction, aldehyde or ketone treated with hydrazine, hydrazones are formed. These hydrazones further heated with KOH in ethylene glycol. KOH in ethylene glycol, hydrocarbons are formed. This reaction, it is known as Wolff-Kishner reduction. Known as what? Wolff-Kishner reduction. Thank you.